Greetings, my students of chemistry. Welcome back to the 6th video of this basic chemistry series. We've discussed a lot in the previous videos. So I will advise that if you have not watched the previous videos, go and watch them before you come to this one. And before we begin, I want to appeal that if you have not subscribed to this channel, click on that subscribe button there and tap that bell icon close to it so that anytime we post a video, you'll be notified. Now, in this section of the series, I want us to quickly discuss mass number. The way we now discuss the mass number, we now combine all you have learned from video 1 to video 5. Okay, we combine them in one piece here with general examples. Before then, the phrase mass number is the number of protons and neutrons in an atom. Mass number is number of protons and neutrons in an atom. In other words, mass number is protons plus neutrons. Take note of this. I've told you before that atomic number is a serial number. I've explained that one before. Now, mass number is what? Protons plus what? Neutrons. In other words, so make a copy of this formula, you keep it. In other words, if I want to find number of neutrons, I'll take protons to this side. Then I have formula 2, which is neutrons is mass number minus what? Protons. And because protons, the number of protons is the same thing as atomic number, we can say also that neutrons is mass number minus atomic number. Take note of these formulas now. Okay? And finally, take note of this before then we can generalize our study. That if I have something like Na, you know that Na is 23, is sodium, and I have a number here and a number here. Anytime you see an element that has a number up here and down here, the number down here is the atomic number. Then the number up here is the mass number. Are you following? If you see something like this, the number up is the mass number. Your number down is what? Atomic number. Take note of that. So these are the 4 formulas I want you to have as we now go into the generalizing our study. Now, to practice this now, what I'm about to do now is the main reason I've done videos 1 to 5. When we pick an element, we'll analyze the element completely. E.g., let us analyze sodium, or rather, let me use aluminium. Now, look at that aluminium there. The atomic number is 13. And the mass number is what? 27. Are you with me? I know you might want to ask me how to get mass number. Well, there are some formulas you can use to get mass number on your own. Like some of those elements whose atomic numbers are even numbers. Something like oxygen. Oxygen is number 8 in the periodic table. So the atomic number is 8. If you want to get the mass number, multiply it by 2. It means that the mass number of oxygen is 16. Are you following? Something like calcium. Calcium is number 20 in the periodic table. So multiply it by 2. That's 40. It means that the mass number of calcium is 40. So if the atomic number is an even number, multiply it by 2. You get the mass number. Is it clear? But if the atomic number is an odd number, something like sodium. Sodium is number 11, right? If you want to get the mass number, multiply 11 by 2 and add 1. So 11 times 2 is 22 plus 1, 23. That's how to get the mass number. Something like this aluminum now, the atomic number is 13. So multiply it by 2 now. 13 times 2 is 26 plus 1, 27. So please take note of this. But even though we have these formulas, there are exceptions. The exceptions are something like hydrogen. Hydrogen is 1 and the mass number is 1. Okay, so let's continue now. So if I want you to analyze this element now, it implies that the atomic number is 13. So take note of that. The mass number is 27. Are we good? The number of protons is the same thing as the atomic number. We are combining everything now. The number of electrons is the same thing as the atomic number. Then the number of neutrons, you check that formula, those formulas I gave you. Neutrons is mass number minus atomic number. Check it there. So it will be mass number Mn minus atomic number An, which is the mass number is 27, atomic number is 13, which gives us 14. Are we good? KLMN electronic configuration of this. I have taught you how to do it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it is 13 now. And please let me remind you now. Very important. Anything you are doing here now, anything you are doing for an element, use only the atomic number. Don't use the mass number for anything except you want to find number of neutrons. The only place you use mass number is where? If you are looking for number of neutrons. Take note. If not, anything you are doing here, use only the atomic number. Okay? So now we have 13. So that's why it's like this. So it will be 2, 8, and 3. Are we good? Now, we move further. Okay, for G, is the element a donor or an acceptor? I've taught you guys before. How many does he need to complete this last shell? He needs 5, right? Can he get 5? No. It's more than 4. So he's going to give out these 3. He's going to give it out. That means it is a donor, right? That means it is a donor. It is a donor with valency 3. Why is valency 3? Because it is giving out what? 3 electrons. Are we following now? So, oxidation number is plus 3. Why plus 3? I've taught you before. Plus because it has lost electrons. Then 3 because it has lost 3 electrons. Okay, so plus because it has lost electrons, and 3 because it has lost 3 electrons. Okay, then I, what's our I now? Our I, let's look at ionic state. What's our ionic? Our ionic state will now be Al 3 plus. Why is it 3 plus? Because plus means it has lost 3 electrons. Then 3 because it has lost 3 electrons. Okay, so take note of that. And the next one, which is J, is SPDF. SPDF electronic configuration. So we'll make use of that formula that I gave you in video 5. SPDF. The SPDF will now be 1s2, 2s2, 2p6, 3s2, 3p1. Compare it with the formula you copied from video 5. You'll see that we have this now. Now, if you fill the orbitals, we have 1, 2, 1, 2. This is 6 now, so we have 1, 2, 3, 4, 5, 6. This is 1, 2. Then this one is P has, remember that P has 3 boxes. So we now have, it has only 1 here, so we have 1. You see it now? That's the SPDF electronic configuration. Now let's summarize. All the electrons here are paired, but there's only one unpaired electron. So we now write number of unpaired electrons equal to number of unpaired electrons will now be what? 1. Is it clear now? That's how to analyze an element. All right. So let's quickly run through another element again. Then we'll now round off the video. Let's look at these elements. Let's look at chlorine. Or rather, let's use oxygen. Oxygen. Now, you can follow me to analyze now. What's the atomic number? Atomic number is 8, right? The one down here. Mass number is 16. Okay? Number of protons is 8. The same thing as atomic number. Number of electrons, that's number of electrons is 8, right? Number of neutrons is mass number minus what? Atomic number. That's 16 minus 8. What will be the K element? Electronic configuration. What will it be? It will be 1, 2. You know, I told you always use only the atomic number, right? 1, 2, 3, 4, 5, 6, 7, 8. So which is what? 2, 6, right? So 2, 6. Now we have 2, 6. How many electrons does it need to complete the last shell? How many? It needs only 2, right? And it can get 2 because 2 is less than 5. Okay, so it will now be, we now say it gains 2 electrons. Okay, that means it's an acceptor with valency valency 2. So the valency of oxygen is 2. Now we have oxidation number. Oxidation number will be -2. Why? Because it gains 2 electrons, right? It gains 2 electrons. Then ionic state will be O2 minus, because it has gained 2 electrons. Okay? It has gained what? 2 electrons. Now, the next one will now be SPDF electronic configuration. SPDF. So use that formula that I gave you in video 5. It will be 1s2, 2s2, and 2p4, right? If we do it now, we have 1 2, 1 2, 1 2 3 4, right? So how many unpaired electrons are here? 1 2 unpaired electrons, single electrons. So we now have, so okay, number of unpaired electrons is equal to what? 2. Have you seen it now? So this is the analysis of an element. You can try some. Let me give you some to do on your own. You can try this on your own. You can try potassium 39, 19. Try sulfur 32, 16. And try carbon. Carbon is number 6. So you can try these ones. Use them to get used to the analysis of an element. Okay, so this will be the end of the video. If you have learned something from this video, don't forget to click on that subscribe button if you have not subscribed. You can also click on the share button, or you can also click on the like button to like the video. And then in the next video, we will be talking about chemical formulas. Okay, so I believe you have learned something very well from this video. I will see you in the next video. Thank you very much.